Hello, in this SFML video we are going to be covering live input, or also known as real-time input. So what is real-time input and how does it compare to events? Because real-time input, you can use it to handle stuff like keyboard, mouse and joystick. Don't say events, you can use it to handle inputs basically. So what's the difference between events and live input? So first of all, let's just run this with the event code so you can just see what we get. So ignore these values for now. Actually, these values are just coming from my joystick. I disconnect that so that doesn't get in the way in the console. If I click the left mouse button, it says left key has been pressed and released. So if I keep it pressed, it will constantly say pressed, but there is one problem with this. One, the actual frequency of it doing this is dependent on the OS, and we want for something like, let's say, gameplay, like movement of a character. So when the left key is pressed, you want the character to move left. You want that to be constant across all platforms or operating systems, and you want generally a smooth experience. Events are great for just detecting when something has occurred, so maybe the window's resized or closed, or even for button events as well. So if you are creating some sort of button class that the user can obviously click, you might want a pressed and released event on it. But generally speaking, for gameplay, you'll want real-time input because that allows you to check for a particular type of input wherever you are, instead of having to create all of these complex window poll event system, which if you wanted to check something in another class, which you probably will because it's good to create object-oriented code, you'll probably maybe pass in the event or the event type, or you might set some sort of boolean triggers in here and some sort of values that you're trying to pass around, and it becomes a mess. So instead of using events, what you can use is real-time input, which we're going to cover in this video. And real-time input isn't a replacement for events, and neither are events a replacement for real-time input. They have their merits. For starters, real-time input only allows you to do stuff like keyboard, mouse and joystick input. It doesn't have any of these window events or any sort of window input at all. So for starters, you'll need events for handling those particular situations, and you'll need events for when you just want to do something when a particular event occurs instead of checking when input has occurred. It might sound a bit confusing at the moment, but let's just get rid of this code, dive into the real-time input implementation, and a lot of it will become clear to you. So if I get rid of that, and to do real-time input, it's pretty simple. The first thing we're going to cover is how to check if a particular key has been pressed on the keyboard. To do that, you just do if. You don't have to do any sort of event variable and poly events. You just do if SF keyboard is key pressed, and now in here you pass in the key you're checking. So SF keyboard key, and I'm going to check the left key, and in here I would just put something like std cout live keyboard input, and I'm going to say left key like so, and I'm going to do std and line, and now if I run this, we'll see how real-time input works. So where is my window? My window has not appeared because I forgot on Mac you need to always handle one particular event, which is the close event. So if I just quickly implement that, so SF event, so while event.poll, no, window.poll event, and let's just handle it so by doing switch, and we are switching on, what are we switching on? We're switching on event.type, and in here it's going to do case, and the case is going to be SF window closed. Actually, nope, that don't look right. I might be mistaking the event. So close, there we go, close the event. And if we do a break, and if this occurs, we're just going to do window.close. And if we run this now, make sure this has been implemented successfully. Yep, that's appeared. So if I click the left key, as you can see, a bunch of couts were printed out. And the reason for that is you get an input live and it's constantly occurring every single frame. So this is exactly what you want for your gameplay. Not only can you check it anywhere you want very simply instead of having to deal with events. So if you have some sort of class which probably would be used within this sort of while is open loop, you could just say if, let's say, particular key is pressed, then do some sort of functionality. So that's how you check if keyboard is pressed. What about mouse? Pretty simple. All we can do is copy and paste this, change this to mouse, change this to button, and instead of passing in a keyboard key, we're going to pass in a mouse button like so. And I'm going to say live mouse input, and I'm going to say mouse button. So if I run this now, okay, so if I hover over it and I click the right mouse button, doesn't do anything. If I just tap the left mouse button, because it's live input and we're getting a cout, or we're doing this check every single frame, we are getting a whole heap of logs. So that is how you do real-time input for the mouse. Now let's cover some of the other properties that you can get for the mouse, such as the position. So the first type of position we're going to cover is a global position, and you need a SF vector 2i because that's what it returns. And so let's just put global position equals SF mouse get position, and I'm simply going to do std cout global position.x global position.y std end line. And now if we run this, what we'll get is the position of our mouse. You might be thinking these values look really high, because in a previous video I said the top left of the window is 0, 0. It's the global position. So as you can see, it's actually relative to the screen. So this screen has a resolution of 2560 by 1440. So in the top left it's 0, 1440. And now I can't quite get to 2560, but that's what the resolution is. So that is the reason why I can't actually get a proper position. I would say a proper position, a local position. So let's cover how to just get position relative to the window. So to do that, I'm going to copy and paste this, and we'll comment out this line, and I'm going to call this local position, and replace this with local, and to get a position that's relative to the window, all you do is pass in the window that you are dealing with into the get position method, and now it's relative to the window and not relative to the screen. So that's how you deal with positions anywhere you want. You don't have to do the event system at all. Also, you can set the position as well. So what we're going to do is, when the left key is pressed, we're going to do SF mouse set position, SF vector like 2i, blah blah blah, and the position we're going to set it to is 100 by 75. Actually, no, let's do 0 by 0. like so. And now let's run this. So we'll set the position when we press the left mouse button, and it sets it to the top left. But what if we want it relative to the window? We can do that as well. So if we copy and paste this, and instead of doing 0, 0, we also need to pass in a parameter of the window as well. So this will set the position of the mouse cursor to 0, 0 relative to the window, which will be the top left of the window. So my mouse is over here, click the left mouse button, and it goes to the top left of the visible window. So that's how you get and set the mouse position. You can also do real-time input for joysticks as well, so let's cover that. So the first thing we're going to check is if a joystick is connected. So we do if joystick is connected, and the parameter that it takes is the joystick that you are checking, and this will range between 0 and 7 because SFML supports up to 8 joysticks or 8 game controllers, like an Xbox One or a PlayStation 4 controller. I think 8 is quite a large number. Frankly, I would like to know if there's any SFML games out there that use 8 controllers in a meaningful way, and not just like as a test bed, like in a meaningful way. I would be really interested to see if there is. And also, if there was only 4 controllers supported, that would be more than enough. 2 controllers will get the job done for most multiplayer games, but well, SFML's provided a whole heap of functionality. So in here we just pass in the index, so I know I've only got one particular joystick connected. I did actually disconnect it, but I will connect it in a second. But because I've only got one that I will be connecting, I'm going to check for 0, and in here I'm going to do std cout, and this is going to be joystick 0 connected std end line. So let's run this now. So what I'm going to do is insert the joystick. So I'm going to plug this in, and as you can see, it says joystick 0 is connected. So let me also do an else here, which simply says joystick 0 is disconnected, so you can see the difference, because otherwise it's hard to see it. But if we run this, by default my joystick will be connected. And you know what I'm going to do is get rid of the cout for the position, because that's just the outputs in the console is getting in the way. So in here I say joystick 0 connected. If I disconnect it, joystick 0 is disconnected, and it's constantly checking for the joystick instead of just occurring when the event occurs. So in a particular, say, character class, we could constantly check if a joystick is connected or if a joystick is doing this. And if we connect it back, it says joystick 0 is connected. Pretty darn cool. Next, what we're going to do is check how many buttons our joystick has. So assuming it's connected, I'll comment this out because this will get in the way. Assuming it's connected, we want to do unsigned int button count, and this will be equal to sf joystick get button count, and the parameter we pass in the index of the joystick we want to check, which happens to be 0. It's always the same as this one, and we're going to do std. I'm going to say joystick 0 has button count. I'm just going to put something here that just says buttons, so we know exactly what this cout is referring to. std end line. Now if we run this, this will let us know how many buttons we have. So joystick 0 has 14 buttons, so that's how you check for properties of your joystick. We can also check if the joystick has a particular axis as well. To do that, you just do bool. Let's say we're going to check for the z-axis has z equals sf joystick has axis, and the first parameter is the joystick or the index of the joystick that we're checking, so 0, and the axis you just do sf joystick, and we're going to put axis, and now a particular axis that you want to check, because not all joysticks will have all these axes. So I'm going to check for Z. I know it actually has this axis. So I'm going to do std cout. Actually, I don't need to see it. I'm just going to say has z std and line. Actually, I will. So otherwise, it might be a bit confusing what's happening. Joystick 0 has Z axis, and I'm going to put a colon so we'll see whether it has it or not. And I'm going to comment this out to prevent this from getting in the way. And let's see what it says. It says joystick 0 has the Z axis. So if your joystick didn't have a particular axis, it will tell you. And if that did occur, you could maybe inform the user that they can't continue because their gamepad isn't supported, or fall back to some sort of other input method, maybe something on the keyboard or something on the mouse, or another axis altogether. So now we're going to check how we detect if a particular joystick button has been pressed. To do that, very simple, very similar to checking if a keyboard or mouse button has been pressed. So we do if sf joystick is button pressed. So first of all, we pass in the index of the joystick we're checking, which is 0. For the button, we put 1. You can put whatever you want. So this is the button that you would be checking. I know what the button 1 or the number 1 refers to in terms of a button on my controller. I have a PS4 controller that I've got connected, and it refers to the bottom button on the face button, which is the X button. And I said button like 20 million times in the last 2 seconds. So in here, I'm simply going to say std cout button 1 has been pressed, std end line. And now if we run this, if we press a particular button, so the X button, it says button 1 has been pressed. So that is how you check for a button being pressed using real-time input on a joystick. And the final thing we're going to show you is how to get the axis position of, well, a particular axis. So I'm going to comment this out so this doesn't get in the way. And to get the position, let's do a float variable, and I'm going to get the X position. And I know my joystick has a X-axis equals SF joystick get axis position, and the first parameter, as usual, is the joystick or the index of the joystick that we are checking. So 0 for me, and the axis, you just put SF joystick axis, and I'm going to check for the X position. So this gets the particular value, which ranges between, I think it's -100 and 100. And now we're going to see this out to the console. So cout xpos std and line, and I'm going to just do some more contextual console login. So I'm going to say X position on joystick 0 is. Run this now and let's see what we get. So it's printing it off as -1, -3. I'm moving it now to the left. It's on my joystick or my game controller. It is the horizontal axis for my left joystick. So if I move it all the way to the left, it's -100. If I move it towards the right, it begins to get close to 100, closer, closer, closer. And if I suddenly move it, it gets to 100. I've let go of it, and it is roughly at about 0. There we go. So that is how we check for real-time input in SFML. So to recap, real-time input supports keyboard input, mouse input, joystick input. Real-time input is great for stuff like game logic, such as moving a counter. Events are great for stuff like text input. It is great for something like if you've pressed a button, so you don't want to, constantly be pressing the button. That's something that you do not want. Another example, a Flappy Bird would actually use something like an event system, because you don't want to be moving the bird like up every single time or like every single frame. It's only when the actual user either presses the screen or releases the screen, or presses the mouse button or releases the mouse button. So there are gameplay situations where the event system will serve you better than the real-time input. It will just be dependent on your particular game scenario. So thank you for watching. If you have any questions, feel free to post them on my educational platform, sonarlearning.co.uk. There'll be a link in the description. Alongside, there will be a link to the GitHub page, which will contain all of the source code from this video and every other video in this series. If you like the video, please give it a thumbs up, hit that subscribe button, and leave us a comment. And as usual, thank you for watching, and I hope you have a great day.